Let's write some code. Or I mean, copy and paste some code. This is it, folks. The culmination of months of work, or, maybe days for you overachievers blasting through the website. We have everything set up, and today we'll update our permissions and deploy the code to enforce our desired security outcome. Oh, yeah, you forgot what that was? Me too. Let's take a moment to review. We started all of this because we couldn't create a resource control policy that could build a rule for us. And the rule that we wanted, that security invariant, is that if an S3 bucket is tagged with the classification of sensitive, only allow access to that bucket from within our AWS organization. Now, we originally hoped to set that up using that resource control policy, that RCP, but there's this limitation in IAM and RCP conditions and service control policies. And they don't support bucket tags, so you can't use that an S3 bucket tag as a condition in those policies. But then me, decided we could achieve the same objective with an auto-remediation guardrail that will trigger whenever anyone tags a bucket or makes a permission change to those buckets. And while policies like SCPs and RCPs are great because they prevent something from happening, they can't really handle all the complex scenarios we might encounter out there. And so for those situations, we can use a corrective control that fixes something after the fact. And that totally is still what we would consider a security invariant, and especially because these can often operate almost instantaneously thanks to the power of cloud. So here's the diagram of the logic that we built out. And what we're doing is we are monitoring CloudTrail for certain API calls, and we're using those as our triggers. Once those trigger, we assess the bucket, and then we apply the corrective controls to lock it down. Now, to this point, we've set those triggers, and we did that with our event bridge rules. And we've linked them in to run our Lambda function to get the information from the bucket. And that establishes all of our we also established all of our cross-account access and our role chaining permissions. With all of that set, what's left is just the actual remediation code itself. And really, there isn't much more to say about it in terms of like a generalized lesson, like I do at the start of a lot of these videos and labs. But there are a few points in terms of how I designed this particular function that might be interesting. As a reminder, the main body of a Lambda function is typically called Lambda_handler. And this is what gets sent into it. It gets the event and some header information, the context. And that comes from when we set up that trigger from EventBridge. From there, in our code, and what we've already implemented is that we extract the account ID of the account where the event occurred, because we're monitoring for lots of different accounts. And then we extract the name of the bucket from the event as well. And this is because we're just focused on S3 right now. So we pull the account ID so we know what account that bucket's in, and then we have the name of the bucket so we can go do things. The function then assumes the target role in the target account and uses the function that is called get_bucket_info. I'm only mentioning it because if you're looking at the code, you'll see it. And that function gathers all the information that we need to make our security decisions, including the current tags and bucket policies, block public access, and if it has any access control list, ACLs in place. Now, if that bucket is tagged with the classification of sensitive, then we want to go do things. And that's what we're going to do this week. We're going to turn on block public access, we're going to disable ACLs, and we're going to check the bucket policy and add some conditions to the bucket policy. If there is a bucket policy there, we have to pull it out, add the conditions, and put it back in. If there aren't any, we need to go ahead and just create a bucket policy that's going to lock things down to our current organization. And all of this is to go back to achieve that desired security outcome, which is if a bucket is tagged with the classification as sensitive, it can only be accessed from within our organization. So for this function to work, we do need our organization ID. And we're running this in the security operations account, so that does not have permissions to go check what the organization ID is. It doesn't actually have a way to pull the ID because it doesn't have any IAM permissions for AWS organizations. Instead, what we're going to do is I'm going to show you how to set it as an environment variable because it's just a good excuse to see how environment variables will work for Lambda functions. And to make this lab easier to understand, I wrote all the code into a single file that you can copy and paste into the console so you see everything at once. That's not necessarily how I build everything, but it is how I do it for these kinds of demo labs because it makes it easier for you guys to all follow along. You're not going to have to look into a bunch of separate files to figure out and track that logic. The code itself is pretty well commented and should be easy to follow even if you're new to Python. So to follow the code, you want to start in that Lambda handler function at the bottom, and then you can walk through all the logic in the various functions. For this lab today, I'm not going to go ahead and walk through all of those because that does take a lot of time. And if you want to see that, you could actually, if you're a Cloudslaw Pro Patreon subscriber, I have the video where I actually wrote all of that code and I did it using AI. Now, this code, as I'm giving it to you today, will work well in a lot of situations. But the one place it's not going to work well is it doesn't have any IP-based permissions. So if you want to allow access based on an IP address, as opposed to managing it with IAM and an API call, that is not going to work. Now, we can write more complex code that can evaluate and have allow lists and block lists for IP addresses. So you could like restrict things if it's only a private network or only from specific IP address range. But that was beyond our current requirements. So just really keep that in mind. That is a really important limitation if you try to write your own code or implement this in your own environment and you need to extend it to deal with IP addresses. Now, you'll also notice in the code, I didn't rely on any bucket information from the event itself. And we get some of that. Like if you change the tag, we see that in the information that comes across in the API call. All we're doing is we're pulling out the bucket name and the account ID. And the reason is that when I write autoremediations, I always want to check the current state of the resource before making any changes. Because life comes at you fast, especially in cloud, and things can change from when you actually pick up that a change was made and when you actually go to do your autoremediation. And you still might have timing issues, but for the most part, the way this one works, it should be pretty reliable. Now, writing this code took me about an hour, and I used actually AI to help me. It was pretty useful. It's not a substitute for writing your own code. I knew what I needed to do. I knew how I wanted to structure the code. I even found when it was making mistakes with the wrong API calls. But that's what I did to speed things up, because normally this would take me like half a day to do. And that was one of the cool things. It really did take me less time than I expected using the AI as an assistant. Another thing is that I used our test event to trigger the autoremediation every time I wanted to test it, but I had a real target bucket that I was working with that I could safely make changes with it because I had to check the different conditions and I had to change all the variables. And you can mock this stuff up if you're doing your own local development. That was beyond the scope of what we wanted to do here. I just like to use test accounts sometimes, and then I can set that resource the way I want it, and I can just flip it back and forth in terms of changing the various conditions. So again, you can check that out in the pro content to see if you want that deeper walkthrough about how I actually built it, and you can see how I actually tested everything. Now, finally, to make all of this work, we also do need updates and permissions, and we need to set up the environment variable. And to be honest, that's going to be most of the lab because the code itself, we're mostly going to just copy and paste it into place. So with that, let's get started. We're going to start by updating our stack set permissions because I didn't get them all right, and I knew they weren't going to be all correct until I actually wrote the code. And then we're going to pull the organization ID, and we're going to put that into an environment variable. Let's get started. Is go ahead and get our organization ID. So we'll get that from our management account. So log in, go to administrator access in the management account. And then we will go to organizations. Dun, dun, dun. I like clicking it up there. Nice and easy. Go to organizations. And we will just pull our organization ID from there. And we're going to just throw that on our clipboard because we'll set that up as a variable in the first thing we do. And we won't be doing any other copying and pasting until we set that up as that environment variable. So close it. Now we want to go into our security operations account. And we'll go with administrator access. From here, we'll go into Lambda and into our Lambda function, security auto S3. And within Security Auto S3, we're going to go to configuration. This is where we'll set our environment variables. And I think I might have messed up and left the environment variable there from when I was testing. I did. So, but you would go ahead and add an environment variable. And let me go ahead and I'm just going to remove this, save it. There we go. So click on environment variables. There's no environment variables, so let's click edit. And we're going to add an environment variable. And we call this org_ID. And we're going to validate that to make sure it works. And we paste in our organization's ID and click save. So this is great. So now that this environment variable is set up here, our code can access it. And if I actually flip over and show you the code, this is in my development environment here, you can see that it's going to look for that org ID. And it pulls that. Let me find that code in the environment variable section here. I'm going to pause as I go to find that. And it was just slightly above where we were looking. So it actually is this line here, org ID equals org os environment dot get org ID. So you can pull your that, make sure that I'm matching it and I'm looking for the right thing. Okay. So back in here into the Lambda function. So we have our org ID set. And then the next thing we're going to do is swap in our code. And we're going to go over quickly and get that from the blog post. You can get the big blob of code. So we're going to go to code. And then I want to replace all of this code here. So let me go grab that from the blog post. I'm going to pause while I grab it. And actually, I'll just show you. I'm pulling it directly from my editor here. This is the same code. So I'm going to copy all of that code out. You'll get it from the blog. Go into here, Command A, select everything, V to paste it in. I'm just going to make sure all the correct code is there. Yeah, so this has like an action on it, disable ACLs if they are there. So I know this is the fix things code. And I'm going to click deploy. As a reminder, that's basically like saving the code and pushing it out there. Now, I am going to show you very briefly what some of the code does here. I'm going to do it in this. Actually, I'll do it over my IDE. It's a little bit easier to see it. I'll move this window down here. Okay. And so as I scroll all the way down, I mentioned the Lambda handler is where all the main code exists. So this is where the core of the code runs from. And if you recall the logging that was there last week, assuming a role that was all there last week, pulling the bucket name that was all there last week. So that was all what we did have. But then is sensitive. So if it is sensitive, so it's looking for the key of classification and a value of sensitive in the bucket information as one of the tags, and it has to check across all of the tags. So that's kind of what that language does. And so it sets that as true or false. And if it is true, then it says it's tagged as sensitive. And first thing it's going to do is do block public access. If that's turned off, it's going to turn it on. Then it's going to go through and deal with the ACLs. So it's going to check the ACLs, and there's another function up above, and then it's going to disable ACLs, so you can't use those anymore. And then it's going to modify the bucket policy. And all of that comes up in these functions that are higher in the code. So you can actually walk through all of these piece by piece and see, how do we set BPA? How are we setting the ACLs? And the bucket policy is the tricky one, because if there's an empty bucket, we have to actually if it's an empty bucket policy, we have to create one. If there's an existing one, we're just adding our deny statement to the existing policy. Okay, so we have all of that saved and we have all of that deployed. Now, if you go to test this right now, it will kind of work and then it's going to fail. But let's go ahead and just test, and you'll see actually the success code on it. And we'll give it a minute to run here, because right now it's just doing the read access. It's not trying to make any changes. And you can see down here, the reason for that is, if I go down into the results, there's everything right here. This is the line I was looking for. That bucket is not tagged as sensitive. So as a result, this code is not running right now. And we can make as many changes to the bucket as we want. As long as it's not tagged as sensitive, it's not going to go ahead and do anything. Well, if it does try to do something, it's going to fail. And why is it going to fail? Because we don't have the proper permissions. So the first thing we're going to do is go fix those change permissions, and then we're going to modify the bucket, and we'll actually see what it actually does, the changes it makes to the bucket. To do that, we're going to switch over to stack sets. Remember, this account has permission for CloudFormation stack sets. So go to CloudFormation, and then we'll go to stack sets, and we'll go to service managed, and we'll go to the autoremediation role. Now there's a couple of things. The first thing you need to do is copy this OUID. You might remember this from last week when we modified permissions. I'm going to copy that onto my clipboard. Now from here, I can go to Actions, Edit Stack Set Details. And instead of modifying the current template, I have a new version for you. And let me go pause. I'm going to go grab that URL myself. Okay, so I have that URL. Let me paste it in. I did test this before, so hopefully it actually works this time. And I'll go click Next. Then we leave all of these settings parameters because we're only updating the stack. We're not really doing anything else. We're just changing the template. Click Next. I'm going to acknowledge that it might create IAM resources with custom names and click Next. Now we do have to add the OUID, so let me pull that from my clipboard. And I've pasted in the OUID that I had from before, and we'll just hit Add All Regions. And again, this is only deployed in one region because it's an IAM role or IAM policy for a role. And we'll go ahead and click Next. And we'll scroll down and we'll click Deploy. Submit, not deploy. This should go pretty quickly. It took about a minute in my testing before, and I'll just go ahead and pause while it runs so I don't bore you. That wasn't even a minute. I barely had time to respond to a meaningless text message. Okay, so the new permissions are up to date. Now, how do I know that? Well, I can go to Template, and I can see in the template, if I look at the permissions, these were the ones that I updated. So I can make changes to ownership, block public access, and then putting and deleting bucket policies. So that's the intention of what I had in there. I actually slimmed down and had some other weird permissions. This might actually even be over permissioned a little bit. I was kind of planning for some other than S.L.A.W, so we'll see. I'm not going to guarantee that we're not going to have to make any other changes. So now we have permissions, and we have our Lambda function, and our environment variable is set. Let's go ahead and test it. And the way we're going to test it this time is I'm not going to run the test event because right now it wouldn't do anything because the resource does not have the tag on it that we need to actually do the test. So I have to cross over into the account where that bucket is. So as a reminder, if we go to S.L.A.W, Administrator Access, and then we're going to do our switch role again. Let's click up there. Now remember, this should be in your role history. If you are bouncing around browsers, just go back to last week's lab or just go click on switch role. You just need the account ID for the production one account. And we're doing this with the organization account access role. Again, this is an account we're messing around with, so we just didn't add it to IAM Identity Center. Although you are free to do that as well, then you wouldn't have to go through this process. All right, I'm going to switch on that role history. It's going to drop me right into that account. Right where I was last week. I'm going to go to S3 and click on the one S3 bucket we have for our testing. Now, real quick, I'm going to show you permissions. Block public access is currently turned on. I want to make sure for testing purposes we test this. So let me go to Edit, and the default is to turn it on. I'm going to disable block public access, save changes, and type confirm. Now, this change alone is going to trigger the auto remediation, but it's not going to do anything. Why not? Even though it's now running in the background, because this is not tagged as sensitive. I'm going to validate, so I have that disabled. So technically we could, it doesn't mean this is public. It just means that it could be made public right now. There is no bucket policy and object ownership. It says bucket owner enforced. And the key phrase here is ACLs are disabled. So all of the different ways. So even though there's some ACLs that are listed here, you'll see that it's just bucket owner stuff. There's no outside access. So this bucket is right now and actually let's change that as well. So let's go to object ownership because I want to show you how this works. Let's click edit and ACLs enabled. And we want to acknowledge that ACLs will be restored and thus this could be used to expose the bucket. Again, we don't even have anything in here. We don't have anything in here. It's not exposed yet. We're just taking off all the security controls that prevent it from being exposed. We're not actually exposing it. And there's no data in it anyway, so it doesn't really matter. Okay, I'll click Save Changes. So now block public access is turned off. So somebody could, if they opened it up to be public, they could. The bucket policy doesn't exist, which is fine. So there is no access. And then the access control list is now basically enabled. So bucket owner is preferred, and it says ACLs are enabled. And we, as a reminder, this is all the stuff we're going to turn off. But nothing's happening. So if I hit refresh, where's refresh? Right here in my browser, all of this is staying the same right now. Even though we made changes, this is triggering our Lambda function, but it's not doing anything. And you could go into the logs and the CloudWatch logs and look. And I do encourage you to do that on your own. You'll see that the bucket is not tagged as sensitive. Well, let's change that. We'll go to properties, edit. Remember, we had our random tags in here. You might have more or fewer, depending on how much you tested. We're going to go to classification, sensitive, and click, make sure I spelled everything correct. Click Save Changes. So this is now creating that API call that's going into CloudTrail. That CloudTrail is triggering that event bridge event. That event is now appearing in our central event bus in the security operations account that we created for collecting all the security, or at least for the S3 events. That event then, because it is an S3, it is used because we have an event bridge rule in that account that triggers our Lambda function. The Lambda function is running. The Lambda function is checking to see if it's tagged as sensitive. And if it is, it's going to make the changes that I put in from that central account, making its cross-account access into this account. So let me go back over here and let's see in the 30 seconds that I spent talking about that, if it actually changed anything. And whoops, well, of course the tags changed. Let's click on permissions. Look at that. Block public access is now turned on. We now have a bucket policy that denies access from outside our organization. So it's got a bunch of restrictions on here. I might need to actually tweak these a little bit, but we have that bucket policy in place. Bucket owners enforced and ACLs are disabled. That's pretty cool. I made the change. Honestly, it probably took about 10 seconds for most of this auto remediation. About 10 to 15 seconds is typically the timing it works. It's all event driven. If you have 100 people making changes in 100 different accounts, it doesn't matter because every one of those is going to trigger a Lambda function and they're all going to simultaneously be auto remediated. This is very, very, very cool stuff. And we spent a lot of time building this out, but this is what is used for real. I've presented a really cool architectural pattern. This is one that I've been using for years in different ways, shapes, and forms. And I just love the fact that we can actually have these kinds of corrective controls in place. Now, let me go ahead. I'm going to check some of my older diagrams. I'm going to pause for just a second and see if I've got one I can pull up really quick. Okay, back to the whiteboard. I'm going to zoom around a little bit and bounce around a bunch of this. So again, as a reminder, when these triggers, so these events are all the ones that will trigger our auto remediation. We have not done the time-based yet. I'm going to get to that later. So when these events trigger, it's going to check if it's classified as sensitive. And if it is, it's going to do block public access, it's going to disable ACLs, and it's going to insert that bucket policy like we talked about. Now, architecturally, it looks kind of like this. In the security operations account, we've pushed out all of our permissions using our stack sets with delegated administration. We have our event bus that's collecting the events from anything in our production OU. And again, we use stack sets to push that out. So this is forwarding rule exists here. It's forwarding all the events to our central bus. And then that bus has an event bridge rule that when it's an S3 event, it's going to trigger, and in this case, not temporarily our testing, it's going to trigger our Lambda function. When that Lambda function triggers, it's, as a reminder, a Lambda function's in a container in an instance. It's going to pull from the environment variables. It's going to log what it's doing. We built that logger in there, and it has its Lambda execution role that it's using to do things. Then, I think I need to zoom out here and zoom in. So what is that? How does that all part of that work? Well, we have our automation Lambda function. It has its role that allows it to assume a role into the target account. And we're doing that because our code pulls out that account ID. We already know what the role name is going to be. And our Lambda function is pulling out the name of the bucket that it wants to make changes to. It gets all that information, and then it makes changes. This is a lot. We've gone through so much over, I think this is like lab 7 or 8 that we've done here. And we're still not done. We've got to do our time-based sweep to close out this security automation. But I hope you got a lot out of this. This has been a lot of fun for me to build. I've never actually done it like this out in public and trying to fix my mistakes every week as I build things out iteratively. But this is very useful. And this is something that is done in the real world. And it is kind of an advanced skill. With that, hope you have a great week.